Good afternoon, everyone. So my name is Ambroise Thirion. I'm from Labs. And the aim of this presentation today is to give a quick overview about what's coming on for 200 gig and 400 gig on the optical transceiver side. It should be a quick introduction, 5 to 10 minutes before the lunch. We always talk about increasing the bit rates because there is a demand. And when we see the projection from Cisco, etc., that we've seen earlier today, it's always increasing. Until when, we don't know. But there is a demand for this, but not always. There is also a demand to increase the density. There is a cost for the space. And also, very important, there is a demand for the power consumption, to lower the power consumption. That's extremely important. There is also a cost for this. But there is also, with the power consumption, we also have to consider the power dissipation. So this is why we are continuing and why the transceiver industry is continuing to introduce new form factor with new technologies to answer to these different needs. And for the 200 gig and the 400 gig transceiver, we are mainly introducing two technologies. The first technology that we will introduce is the PAM4. You have all heard about this PAM4 modulation. And the PAM4 consists of, per baud, we have in fact two symbols instead of one for the actual NRZ modulation. So instead of having 0 or 1, we have two symbols, so we can double the bit rate on the transmission. And with the PAM4, we can do today 200 gig. Because today, when we talk about 100 gig transceiver, we do 4 times 25 gig. With the PAM4, we can do 4 times 50 gig, 200 gig. To also reach the 400 gig transmission, we are also adding a gearbox. The gearbox can combine 2 flow of 50 gig PAM4 to a single 100 gig PAM4 line. We have to understand that behind the gearbox, we are coming from a baud rate of 25 gig because a 50 gig PAM4 transmission is in fact 25 gig baud rate, and we move to 50 giga baud rate. But then on the transceiver side, we need a new form factor. The form factor, it's the dimension of the transceivers, the electrical interface, and also some other standards that we have to follow. And on the transceiver industry, we are releasing the QSFP56. The QSFP56 is exactly like a QSFP Plus for 40 gig and a QSFP28 for 100 gig. The sole difference is that we are using the 4 lanes of 50 gig PAM4. It means that in a QSFP56 port into a switch or router, we can plug a QSFP Plus or a QSFP28 if the system behind is supported. A new form factor is coming, which is very interesting. That's the QSFP DD for QSFP double density. The main change is that instead of coming with 4 lanes of 25 gig or 4 lanes of 50 gig, we are coming with 8 lanes of 25 gig or 8 lanes of 50 gig. 8 times 25 gig, we can do 200 gig. That will be the QSFP28DD. And for the 400 gig, we can do QSFP56DD with 8 lanes of 50 gig. Interestingly, the QSFP-DD is also in competition with another form factor called the OSFP. It's very similar to the QSFP56DD transceiver. It's just that there is a bit more power available on this form factor. So in the future, will we have QSFP-DD and OSFP together? Will it be more QSFP-DD and less OSFP, or vice versa? It's difficult to say. Some vendors are going today for the QSFP-DD, some other vendors are going to OSFP. I have my own ID. I'm sure that you have your IDs as well. But it's still difficult to predict. But clearly, we see more and more QSFP-DD form factor, but to be checked in the future. This form factor, it's really nice for the short reach transmission, data center application. Why? Because the most important, I mean, not the most important, but it is very important, is of course the power consumption. And the QSFP plus or 28 or 56, it's allowing a maximum 3.5 watts power consumption. When we move to QSFP-DD, we need more power because we have 8 lanes, and we will see after we can also add additional component inside the transceiver. But still, we try to keep the power low, below than 12 watts or 15 watts for the SFP, and in the future it will be below than this, of course. But if we want to do long-reach transmission, it's today technically impossible to do a long-reach transmission transceiver with a small form factor like this and with a limited power availability on the form factor. And this is why we also have the CFP8 form factor, which will enable coherent transmission for the 400 gig over long reach. In terms of application for the 200 and 400 gig, we have the application inside the data center. We have the back-to-back link, less than 2 kilometers. Most of the time it will be even lower than this, with QSFP-DD or OSFP. We can also do the breakout application from the top of the rack switch to the server. And that will be 400 gig to 4 times 100 gig. And how can we do these 100 gig transceivers with the actual QSFP28 we have today? That's something I will explain just after. We can also do inter-data center with some back-to-back links, less than 10 kilometers, but also most of the time for all the DCI metro application, we will use transponder, and again, thanks with the using the coherent transmission with a 64 QAM modulation available on a fixed line card or a CFP8 form factor. And back on the QSFP28 100 gig. Because what we are bringing for the 200 and 400 gig, we can also use this application, this technology, to make a new type of transceiver for the 100 gig. Today, the 100 gig, it's always 4 times 25 gig, mainly for the QSFP28. If we add a DSP inside, we can change this modulation. So it's a 25 gig NRZ modulation on the electrical side. We can combine these 4 lanes of 25 gig to 2 lanes of 50 gig PAM4 with the PAM4 modulation inside the transceiver. If we add the gearbox on the transceiver, we can go from 2 lanes of 50 gig to 1 single lane of 100 gig. The great advantage of this is that instead of having a transceiver with 4 laser and 4 receiver, we have a transceiver with a single laser and a single receiver. There is an application that we have been, which has been mentioned yesterday, about the Colo-Z transceiver, which is a QSFP28 DWDM for the transmission. But we can also use this application inside the data center because, and it's difficult to predict today, but we might be able to reduce the cost of the transceiver because we are removing the 4 laser, the 4 receiver, we are only using 1 laser, 1 receiver. But there is a question mark about the DSP cost. Prediction is that the cost of this one will decrease, but it's difficult to say today, we will see. And thanks to these transceivers, with a single laser, we can maybe use it back-to-back into a data center as well, with a low power consumption. But we can also use it against 400 gig transceivers when we do this breakout from 400 gig to 4 times 100 gig. And to finish this very quick introduction, it's important to also understand, okay, 200 gig, 400 gig, it's great, but do we need it today? Do we have to deploy it today? I mean, by listening to all of you yesterday and today, it seems that 100 gig is still very important. There are many deployments with 100 gig. There is no real need today for 200 and 400 gig. And I guess that the most important is to make sure that you have what you need for your network, and to make sure we have the right technology at the right cost at the right time. So here we are showing some numbers from light counting, where in fact we have the shipment of transceivers, so with 10 gig, 100 gig, and then 200 and 400 gig shipment mainly for the 2 kilometers area, where in fact we are showing the amount of shipment together with the availability of the silicon mainly for Broadcom, etc., that we have seen today with Edgecore, the availability on the market. And this year, in 2018, Broadcom, they've released the Silicon 32 ports of 400 gig. But we have to consider that when a silicon has been released, there is always 2 years for the mass production and also having the right cost. Which means that we expect, or based on the light counting statistics, we expect to see the real shipment of 200 and 400 gig transceivers in 2 years. So right now, this year and next year, it's mainly for proof of concept qualification for the operators. We need that. But the real deployment, it's not before 2020. Again, depending on the operator type. Thank you very much. If there is any question, I can answer no, but we also we have a booth close to the lunch area where you can also come and we can discuss and you can ask a question. Thank you.